thank you so much for having me. I appreciate the chance to be here. Talk about a subject that is definitely near and dear to my heart personally. We are, as has been discussed, we're going to be talking about what I see as both the opportunity and truly an imperative for us to think about and evolve to more circular economic models in the tech sector. And the reason why is because we are operating collectively, all of us, at unprecedented scale and in the sector, and technology enables everything that we think about and do today in our personal lives, professional lives, and so forth, especially more so even now. That scale has the potential to have massive impact, both positive and negative. And we think circular economic models are a really important piece of the puzzle as we seek to capitalize on the positive potential and minimize the negative potential. So just, some basic context on circular economic models that will hope to give people the right framework to think about this as we go into the session. In the traditional kind of model that the world has operated in for decades now, we think of it as very linear, right? So we take resources, we make things with those resources, and then we too often dispose of them. And recycling is actually disposing as well, right? So it's better than landfill, but it's still disposing, right? We think of things as having sort of singular use cases, right? Since probably the middle of the last century have moved towards what is truly too much of a disposable and consumption-driven economic model. And that model has proved to put us in a place where we are really depleting the Earth's resources in a way that's unsustainable, right? It turns out that it's also the model that doesn't maximize the financial value of resources and things, and we'll talk about that. But so it's super important opportunity now to be thinking about how do we move towards a more circular model, and that's what we're going to talk about today. I'm going to first set some context for kind of that scale and the potential, both positive and negative, that I mentioned at the beginning. And then we're going to focus on the data center industry as a subset of the technology industry, where we have some really interesting research that we've done to talk about and to characterize the data and the potential, and because it's happening now, right? It's a good sort of mini case study as to how we can think about moving towards more circular models more holistically across the tech sector. Very quickly, first, who's IT Renew? We are in this business, right? We operationalize and orchestrate circular data center models and circular economic IT models. We work with most of the major hyperscale cloud companies to help them think about how they maximize lifetime value of assets, how they think about lifecycle management. We physically decommission equipment from those environments, and then we create secondary markets for all of this equipment, which, as you'll learn more, is the circular model, right? We're creating secondary lives, in some cases tertiary lives, and as we do that, we're maximizing both the financial value of assets, IT assets, but also the sustainability value. Our belief is that to do the right thing to maximize financial value, to maximize the positive potential of technology, is not in conflict with what maximizes the sustainability value, right? It's a core part of our mission to say we want to believe, we want to foster growth in the tech sector, we want to unleash the potential of it at scale in all the best ways, and none of that should be in conflict with doing the right thing from an environmental perspective. So let's just dive in. Scale. IDC says that the global IT hardware industry, IT industry is about $5.2 trillion in 2020. The hardware portion of that, devices and infrastructure, is over $1 trillion, 1.2. That's the 5.2 number is the largest industry in the world, right? For context, and this is very positive context, it's bigger, for example, than the global oil and gas industry, which is about 3.3 trillion, right? So the good news is we are spending money on technology, and we are investing in technology for a variety of very positive use cases, which is, again, at a scale which is almost hard to fathom, right? other ways of looking at this, right? There are about 13 billion connected devices now in 2020, and the expectation from markets and research and Grandview research is that that number goes to 75 billion over the next 5 years. So again, about average of about 10 devices per person globally. If you think about that at scale, in all corners of the world, it's an immense amount of devices that are connecting over the internet and generating a tremendous amount of data that feeds, again, very positive potential, but requires a tremendous amount of resources to deliver, right? Same time, those devices, and we all, and our applications, everything that we do professionally, personally, and so forth, is expected to generate about 520 zettabytes of data by 2025. It's super hard for people to understand what a zettabyte is. So I want to just share my favorite stat, which is that some people are estimating that a zettabyte, a single zettabyte, is the equivalent amount of information to all of the grains of sand in all of the world's beaches globally, right? So again, impossible to fathom. The beaches around Barcelona, the beaches everywhere around the world. Take that and multiply it by 520, and that's the amount of data in terms of information that we're going to process and do something with in the next 5 years. So again, just driving almost unfathomable demand for infrastructure, both hardware and software. And of course, we're going to focus on hardware today because that's the stuff that consumes the physical materials. But it's obviously a massive amount of information that's driving all of this. Now, from a positive potential perspective, all of this investment in technology enables massively interesting things, right? It enables everything that we see in healthcare, especially we're seeing telehealth now. It enables everything we see in, whether it's from smart manufacturing, autonomous vehicles, space travel, climate science, you name it, right? We as an industry, people operating in the cloud sector, people operating in the various application sector, we have the ability to harness technology to do amazing things, right? I mean, people talk about superhuman computing in the not too distant future, right? Immense potential. And the question I often pose, though, is, we talk a lot about clouds. Are our heads in the clouds, right? At what cost is all of this phenomenal investment in technology? And that's where we're going to talk today about how we can potentially turn these things into less costly and more impactful. Couple stats here. Just to showcase again the potential, sort of the imperative really behind this. We generate about 50 million tons of e-waste every year as an industry. To put that in context, that's if you stacked like 18-wheel trucks front to back from New York to Bangkok and back, full of e-waste every year. That number is growing. People are talking about the fact that we need to start mining the deep sea beds for the minerals that are going to make up electronics, because we're going to completely deplete all of the land-based sources for those minerals within the next 10 to 15 years. We're using a tremendous amount of energy, right? There's an estimate that says we're going to consume more power in the tech sector than full energy produced by 2040. Things like AI are, again, incredibly powerful tools, but come at a big cost, right? So there's another forecast that within the next few years, AI alone could amount for as much as 10 or more % of the global energy demands. And as a sector, the most alarming stat, and the stat that I think should compel all of us to really think about how we work together to change some of the practices and become more sustainable, is that as an industry, digital industry, we are on track to go from about 4% of the world's greenhouse gases to as much as 8% in the not too distant future, right? And what that basically means is that as the global community is working really hard to decrease emissions and to work towards the climate change principles of 2 degrees and 4 degrees and so forth, as an industry, we're going the wrong direction, right? We're going from a relatively lesser to a more high percent. And that just tells me we've got to work together to try to think about how we drive innovation differently than we have in the past. The last piece about this is really a humanitarian piece. and the question I would pose is, all of those immense power and positive potential of the tech sector, is it really distributed evenly, right? And it turns out that still, we're getting better. A few years ago, it was half the world's population is not online. The most recent stat this year is about 41% is not online. So we are getting better, which is very interesting. Unfortunately, there's a tremendous amount of e-waste still that goes to, not coincidentally, the same places in the world where the population is not online. So we have kind of a 1-2 punch of some of the developing countries are still hindered by lack of access to infrastructure, lack of access to technology, and populations that are not online and therefore not generating as much economic growth, prosperity, and so forth. But we're also then shipping back a bunch of e-waste, right? So there's sort of a compounding problem in parts of the world that is problematic to all of us, not just in various parts of the world, right? And there's an estimate here from the World Bank about 6 or 9 months ago that says if we were able to get the populations in some of these countries that are still developing online to the tune of like 75%, that could generate as much as another $2 trillion US dollars equivalent of economic impact, right? So massive potential to kind of lift the overall global community. And frankly, COVID-19 has exacerbated this kind of unequal distribution of technology and the impact of not having people online, right? If you think about not just economic potential, but what happens if people can't get telehealth? What happens if they can't do online education? What happens if they can't work remotely, right? So anyway, not only an environmental impact, but absolutely a social impact that is tied to and touched by this situation of kind of pervasive technology and the scale that we're all operating at, right? One more point on this for context setting. It's not just me talking about it, right? The UN set out in 2015 some sustainable development goals, and there are a couple that are directly related to this topic, right? The first one is industry, innovation, and infrastructure. This is about that context we just talked about, which is getting people online matters. It's important. It feeds not only the elimination of poverty, which is goal number 1, but it feeds access to education and equal rights and prosperity and so forth, right? Healthcare, everything else. The point that's most important about here is that there's another estimate that says we're about $100 billion shy of the budget required to achieve that universal access goal, which means that the traditional ways of us delivering infrastructure are insufficient. We have to innovate here in order to drive goal number 9 and to get people online, connected, and so forth. At the same time, there's another one which is very straightforward: responsible consumption and production, right? We cannot keep trashing the planet. We're going to run out of resources. Circular economic models would say, hey, let's not just do this kind of single-use disposable world that we live in. Let's actually truly maximize the financial value and the sustainability value of all of the materials. Goes hand in hand with this, right? So this is circular economy kind of 101, right? So let's look at it in practice. In a circular economic model, rather than that linear model, the goal is keep assets in their highest utility value as long as possible, which means that you have this kind of notion of cascading of assets into lesser value situations for as long as possible, wherein recycling and any sort of waste stream is the least worst alternative, right? So the first thing you want to do is, in looking at the data center industry as an example that we're going to dive into here, is say, okay, what if I have racks of equipment, right? I don't want to just recycle those when I'm done with them. I want to actually take those racks and give them a second life as racks. That's the least kind of transformation. It's the least energy input and so forth. If I can't do that, maybe I can turn those same compute and storage resources into things like edge solutions. So in other words, not rack scale, requires a little bit more transformation, but you don't jump all the way to recycling. Same thing in between kind of edge solutions or other remanufactured type, form factors. You can think about recertifying and reselling components, right? So we're keeping as much as possible out of the landfill and going through these loops of recertification, remanufacture, reuse as long as possible. And as we do that, we're deferring a tremendous amount of new manufacturing, which we'll talk about in a minute, has a very significant carbon impact in addition to just the sheer materials. So that's context. We'll come back to a little bit more of the data center examples in a minute, but some more stats, right? when we talk about e-waste of 50 million metric tons, that's a global stat. In the data center industry, the important stat is servers, right? So these are Gartner numbers that says in data centers that have an average of over 50 servers, 50 racks of servers in them, there are about 65 million servers deployed in 2019. There's about 14 million servers expected to go into those places over the next 4 years. And so you should land at about 120 million servers deployed in the world in these data centers. But unfortunately, what's true is that you end this period of 2023 with 75 million servers. So what that tells you is that there's about 46 million that are coming out over that same amount of time, which again is just a tremendous amount of physical material that's entering the waste stream if we don't do something different with it. So we have this mass challenge, and then we have an energy challenge, right? And the good news is, on the energy challenge side, we are doing a fantastic job, right? You see companies from Microsoft to Google to Iron Mountain to everybody doing a very good job thinking about use phase energy, thinking about deploying green grids, renewable sources of energy, and so forth, which is fantastic, right? This is all essential. Nobody can keep that. We have to keep our foot on the gas here, right? Everything that goes into better energy usage. Cooling is a great example, right? We have to make these data centers much, much more efficient. Submerge obviously playing an important role in this. But the question then is, if we're looking just at renewable energies as the solution to the environmental challenges of the data center industry, are we looking at the whole thing? And it turns out that there's some other really important pieces, right? So energy really hits the use phase, right? When I turn on the racks in a data center, what is the cost of that from a power perspective, financially, and an environmental perspective? And the greener the grids we are, the better we are at efficient cooling. This is essential stuff, right? But we did an analysis recently, late last year, that helps to give us a view of where should we look next, right? If we assume success on continuing to drive PUE with all of this, the energy use phase, innovation, where do we look next? And it turns out that if you look at the process of kind of everything that goes into pre-use, right? So mining of materials, manufacture of components, assembly of systems and racks, transportation, and all of that, everything that happens before you get to a data center, that's the pre-use phase, that's part of embodied energy. The other part of embodied energy is everything that happens post-use. So end-of-life practices that involve generally sorting of materials, shredding, smelting, and so forth, right? We did a full life cycle analysis of kind of standard x86-based data center racks, and it turns out the embodied content really, really, really matters, right? So we're doing a pretty good job, as I said, on the use phase stuff. We've driven PUE down immensely in the majority of data centers. We're continuing to do those things. But if 3/4 of the carbon impact of IT equipment is associated with everything that happens before you ever turn it on, then that gives us a really good place to say, what if we could defer that process? What if we could defer that new manufacturing, right? And what deferring that new manufacturing means is, what if we could enable a second life for that equipment, right? Can I buy myself, can I use that same equipment and defer that whole 76%? It turns out that it has a really meaningful impact, right? Because if you think about the fact that 76% of the total carbon impact, the net CO2 equivalent impact, is associated with the pre-use phase, that embodied content, which is shown in the green bar here, then if you decrease that, what happens if you buy a second life is you decrease that portion a lot. Now, you do absolutely have a slightly higher impact to operational cost and carbon because equipment is running longer, but it's far more than offset, right? So the net impact is about 25% as when you move to a circular model as compared to when you're in a linear model, right? And that's all associated with deferring the new manufacturing. Now, to just put that in context, that same increase from a net CO2 perspective is the equivalent of saying I'm going to get 68% better in my use phase energy, right? So, think about what that means from PUE gains. Think about what that means from other efficiency gains in the data center. That's a big ask, right? We've already squeezed a lot out of the use phase energy. So to get another 60, 70% is a big ask. So this is, a pretty good way of achieving the similar kind of a gain. Now, one of the obvious questions is, well, but wait a minute, does it cost me more, right? I get it from a sustainability perspective. That sounds really good. But are we living in 2015, 2010, where, to do the right thing from a sustainability perspective actually carried a cost and you had to pay more to do the right thing? And the answer is thankfully no, right? If you run these models out and you model out the changes in Moore's law, you model out hardware depreciation, you model out the cost of power, all of these things, utilization in data centers, it turns out that the overall system TCO, which is, again, just the deferral of new manufacturing, is also about 25% better. So significant gains shared by both kind of first life deployment, like the hyperscalers in this case, and second life consumers of the recertified circular equipment, right? So we have a nice opportunity here, which is truly a win-win, which is, hey, I'm going to get the maximal sustainability benefit and I'm going to get better TCO, right? From a waste perspective, also super important. If we just theorize that we could make those 46 million outbound servers that I talked about before, if we could buy them a second life, that would be the equivalent of about over 30 million metric tons of carbon, right? So how big is that? It's almost 7 million cars coming off the road every year. That's an annual number, right? So it's a massive amount of carbon impact that could come just from deferring the new manufacturing of racks in data centers, right? So sounds like a pretty good win. The question is, what does it look like? What does it take to do it? Well, thankfully, open technology, open source hardware, open source software has been really taking the world by storm for the last 5 to 10 years, more on the software side. And that gives us the platform, right? So IT Renew is in the business of doing this recertification of equipment, hyperscale equipment. It's enabled first and foremost by open technology. So super, very important. The open compute community, super important to this. The ODM integration model, super important to this. Our relationships with hyperscalers and the fact that hyperscalers are decommissioning this equipment at massive, massive scale, also really important because that predictability, that availability, the openness gives us the ability to say, okay, these solutions, we can now turn that stuff into solutions that are useful, usable, and accessible by the broader downstream markets. And here's the clincher is that the downstream markets get radically better economics as well, right? So this is what catalyzes and unblocks some of those budget constraints, whether it's the universal access budget constraint or whether it's the fact that if you're a global enterprise, a telco, a tier 2 or 3 cloud service provider, you don't have the budget latitude that a Facebook or a Google or a Microsoft has. You actually have some real constraints. And because we can give you recertified equipment, then you can get it at significantly lower cost than you would get with a proprietary traditional OEM model, right? So suddenly we have the ability to bring things to the markets at scale, predictably, with really significant economics. And the key is, well, again, at what cost, right? Do I have to compromise something, right? And the critical success factor for any circular economic model is it can't be without compromise, right? Everybody on this call, everybody we engage with knows that, like, to do the right thing from a sustainability perspective, for most of human nature, it can't be any more inconvenient, right? It can't come with compromises. It can't be more, it can't require me to do a whole bunch of other stuff, right? It has to be just as easy. And in this case, what that means is no compromise to performance and to quality, and you just focus on outcomes per dollar, right? So if recertified equipment, I can just plug it in, it meets the needs of my use cases, whether that's, Kubernetes, VMware, whatever, OpenShift, or whether that's virtual desktop environments or machine learning environments, whether that's converged environments. If I can just plug this equipment in, and I don't need to worry about, oh, gee, does it not quite give me the right performance or so forth. But if I can match the performance needs of my workload and I get the best outcomes per dollar, then why would I not do that, right? So this is the opportunity we have to do it today, to use the data center industry as a really great example of what is the success recipe for moving towards more circular economic models across the IT industry in general, right? And I would just summarize by saying, again, to the comment I made at the beginning, and I'd love to get into the full detail of this with anybody and everybody at any time, because you can probably tell I'm passionate about it. We didn't talk much about the financial opportunity here, but we've modeled that we think there's about a $50 billion hyperscale value recovery opportunity here, right? So what that means is that the upstream partners of IT Renew, people like Facebook, like Microsoft, like Google, and others, are motivated to also drive this circular economic model, right? Not only are they driving to carbon negative, not only are they driving to renewables, they have a real financial incentive in addition to a sustainability incentive to help these models succeed. And on so then it's like, okay, I got upstream incentive. Then on the downstream side, the financial modeling that we've done says that there's probably about a $10 billion a year market for recertified hardware in this fashion, right? So you get kind of a nice matching right hand, left hand of, I have motivation on the upstream side, I have motivation on the downstream side of people who are like, hey, I need my budget to go further. If I don't have to give anything up in terms of quality or performance, I'd absolutely like to get that 50% TCO advantage, right? And then, of course, we talked about the sustainability impact, potentially really, really significant from a carbon perspective, and the human impact, which is, what if we could take this 50% TCO advantage of hardware and unleash that 40% of the people that are still not online, and unleash that $2 trillion of GDP, but do it in a really sustainable way. So we're not continuing to kind of trash those same environments that we're seeking to benefit, but we can actually really strive to drive the global community towards these sustainable development goals. Then, this feels to me like not just a win-win from a financial perspective, but truly a win-win-win, where we've got kind of both the financial benefit, the sustainability benefit, and the human and social benefit that I think the global community is seeking to achieve, as evidenced in the Sustainable Development Goals.